Hello everyone, I'm Sharmila from SNDT Women's University. In this session, we will learn what is Cayley-Hamilton theorem and how we use it for finding inverse and adjoint of a matrix. Cayley-Hamilton theorem is a theorem related to matrix. So I'll tell you introduction of matrix and types of matrices which we need for this Cayley-Hamilton theorem and a characteristic equation, then Cayley-Hamilton theorem and problems based on that. Matrix. What is a matrix? Actually, matrix is an array or arrangement of maybe numbers, symbols or expressions by using rows and columns. Now you see this is a matrix. Here 1, 2, 3, these are numbers and these are called elements of matrix. So individual items, numbers, symbols or expressions are called elements. Now size of a matrix. We normally write size of a matrix by using this notation m cross n, but we have to read it as m by n. M by n matrix means it has m rows and n columns. So in this example you can see 3 rows and 3 columns, so it is a 3 by 3 matrix. Okay, now let's see formal definition of matrix. A matrix is defined as a rectangular array or arrangement of numbers or symbols or expression arranged in rows and columns. In general, M by N matrix is usually written as this way: A11, A12, A13, etc. A1, A1n, and likewise we write all m rows and then n column, last element is amn. This is an m by n matrix. A matrix is usually, it is denoted by using capital letters A, B or C. Now let's see different types of matrices. The first one is square matrix. Square matrix means in a matrix, if number of rows and number of columns are same, it is known as square matrix. Otherwise, we call it as a rectangular matrix. So you look at this example. Here it is 3 by 3 matrix, 3 rows and 3 columns. Now null matrix means if all the entries, all elements of a matrix are 0, then it is called a null matrix. Now diagonal matrix means it is a square matrix in which non-diagonal elements are 0. These are diagonal elements. So non-diagonal elements are 0 means it is called a diagonal matrix. Now what is a scalar matrix? Scalar matrix means in a diagonal matrix, if all the diagonal elements are same, if it is equal, then we call it as a scalar matrix. Now unit matrix means in a scalar matrix, if elements are 1, non-diagonal elements are 0 and diagonal elements are 1 for a square matrix, then it is called a unit matrix. Now I'll tell you what is a characteristic equation. If A is a square matrix, say order n, then the matrix A minus lambda I, we can perform this matrix operation by subtracting lambda from diagonal elements. See, look at this way. I is unit matrix. So this matrix is a matrix by subtracting lambda from diagonal elements from A. And now determinant of this matrix is called characteristic equation. Characteristic polynomial. When we equate this to 0, it is called characteristic equation. So when we perform determinant operation and expand it, you will get a polynomial like this, and we can equate this to 0, and we call it as a characteristic equation. Now, because it is an equation, we can solve it for values of lambda. The values of lambda which we get are called roots of characteristic equation. It is also known as eigenvalues of the matrix, or it is also known as latent root or characteristic root. See, for example, if A is a 2 by 2 matrix this way, then we can write A minus lambda I by subtracting lambda from diagonal elements, and then when we equate determinant of this matrix to 0 and expand it, we get this equation. So when we solve this equation for lambda, we get the values of lambda. These are called eigenvalues of this matrix A. Now, Cayley-Hamilton theorem. Cayley-Hamilton theorem means it is a very simple statement. Every square matrix satisfies its own characteristic equation. We have seen what is a characteristic equation. If A is a n by n matrix, square matrix of order n, then this is characteristic polynomial. The determinant A minus lambda I. This is characteristic polynomial. Determinant of this A minus lambda I means determinant of this matrix. So that when we expand and equate it to 0, what we get is characteristic equation. It will be an equation of this form. The theorem says that in the place of lambda, if you write A, you get a matrix equation with RHS as null matrix. And here there is an I to incorporate matrix operation. This is what Cayley-Hamilton theorem. This means A satisfies this equation. Okay. So that is the famous theorem, Cayley-Hamilton theorem. Now, how we get A inverse? Look at this equation. When we pre-multiply A inverse, we get an equation this way, right? This we can solve by taking this to RHS. Then we can find A inverse. Now, this is actually very good use of finding any n minus 1 powers of matrix A. Now see, I'll explain it by using a problem. This matrix is given. We have to verify theorem and compute A inverse. So what we have to do? We have to write characteristic equation, and characteristic equation comes this way. And to verify Cayley-Hamilton theorem, we need to substitute A instead of lambda. So A cube, A square, and A, etc. we need to substitute in this equation. So A square you can find by performing matrix multiplication. Again A cube you can find by performing matrix multiplication. Then we need to just substitute these values in this equation. You can see you get a null matrix of the same order. That means Cayley-Hamilton theorem is verified. Now, when we pre-multiply that equation, characteristic equation, we get this equation where we can find A inverse by taking all these expression to RHS. So you get A inverse. Correct? So this is a use of Cayley-Hamilton theorem. Now another example. See, find adjoint of A by using Cayley-Hamilton theorem. See, here also what we need to do is, first we have to write characteristic equation. Characteristic equation according to Cayley-Hamilton theorem, we can write this equation because A satisfies its characteristic equation. Now, when we pre-multiply by A inverse, you get another equation. There you can write A inverse, right? Now, we need A square, which we can find. Then, when A inverse we get by using that, we know already the formula for A inverse by using adjoint. So, adjoint of A is A inverse into A. So, this is another use of Cayley-Hamilton theorem. We can find adjoint of A. So, what we have seen is two uses of Cayley-Hamilton theorem. Thank you.